Welcome to the Explainer. You know that math trick you learned as a kid? The one for the number 3? Well, today, we're going to uncover the secret behind it. And trust me, it's been hiding in plain sight this whole time.
Yeah, I'm sure you were taught that super simple rule, right? To check if a number is divisible by 3. It's quick, it's easy, but the real magic, the why it works, that's where things get really interesting. Okay, so let's just dive right in and put this thing to the test. Let's pick a number out of thin air. How about 2026? So, is 2026 divisible by 3? How would you figure that out, without whipping out your phone? Well, I'm betting you remember the rule.
The trick is, well, it's pretty simple, right? You just add up all the digits. So for our number, that's 2 plus 0 plus 2 plus 6, which gives us 10. And the last step is just to check if that sum is divisible by 3.
And since 10 is definitely not divisible by 3, we know that 2026 isn't either. Simple as that. The trick works. But, that's not really the cool part. The real question, the one we're here for, is why? Why on earth does adding up the digits have anything to do with whether a number is divisible by 3? I mean, think about it. And this is where a simple little trick opens up a door to a really deep and, honestly, beautiful truth about our entire number system. So to really get this, let's try a visual approach. We're going to see how this whole thing builds by breaking a number down into 2 separate piles. Okay, check this out. It's pretty cool. We can take any number, let's use 357 here, and split it into 2 piles. We're going to call them the left out pile and the kept pile. And look closely. You can see we're doing this for each place value, the hundreds, the tens, and the ones. Now, that left out pile, it's put together in a really clever way. See, it's made of numbers like 99 and 9, which of course are always divisible by 3. So that means the entire pile is a multiple of 3, and we can basically just ignore it, which leaves the kept pile. And what's in that? Just the original digits. That's it. That's the only part that matters. And here we see the exact same logic, just with a bigger number, 5678. We split it up again. That left-out chunk is a big number, sure, 5652, but we know for a fact it's a multiple of 3. So the whole question of whether 5678 is divisible by 3 just boils down to one thing. Is the kept sum, in this case 26, divisible by 3? Well, no, it's not. So neither is 5678. It's that simple. Okay, so we've seen it work for a couple of numbers, but how can we be sure this trick works for any number, every single time? Well, to prove that, we have to go from these specific examples to a general proof. And that, my friends, means we need a little bit of algebra. Don't worry, it's not scary. Now, this might look a little intimidating, but I promise it's not. This is just how our number system works, the one we use every day, base 10. The number 2026 is really just 2 thousands, plus 0 hundreds, plus 2 tens, plus 6 ones. That's all this slide is saying. Okay, here it is. This is the key moment. We're not actually changing the number, we're just rewriting it in a really slick way. We're splitting each place value into 2 little chunks, exactly like we did with our visual piles. So 1000A becomes 999A plus A. You see what's happening here? We're pulling out a piece that we know is a multiple of 9, which means it's also a multiple of 3.
So now all we have to do is just rearrange the furniture a little bit. We're going to group all those terms with the 9s together on one side and all the single digits on the other. And what do you know? Look at that. Our left out and kept piles are back, but this time they're in algebra form.
And we know that first part, the left out pile, is always divisible by 3, right? Because it's made of things like 999 and 99. Which means the divisibility of the entire number hinges completely on that second part, the kept pile, which is, of course, just the sum of the digits. And boom, there you go. That's the proof. So this whole thing, it's not just some random weird quirk about the number 3. No, this little trick is a direct and actually really beautiful consequence of the system we use for numbers every single day. It all comes down to the fact that we use a base 10 system. Just think about it for a second. 10 is just 1 more than 9. 100 is just 1 more than 99. 1,000 is 1 more than 999. Because we count in tens, we can always pull out a multiple of 9 from each place value. And if it's a multiple of 9, it has to be a multiple of 3. And really, this is the leap from just doing arithmetic to actually understanding algebra. Arithmetic tells you what to do, add the digits. But algebra, that tells you why it works. It shows you the hidden structure underneath it all. It takes a rule you just have to memorize and turns it into a concept you actually understand. So now that you know the secret, you've got the tools to figure out other divisibility rules. I mean, the rule for 9 is almost exactly the same. Can you figure out why? The one for 11 is a little bit trickier, but it's based on the very same idea, just looking for those patterns hidden inside our number system.
So from now on, whenever you see a simple math trick, don't just memorize it. Ask yourself, wait, why does that work? Because you might be totally surprised by the elegant, beautiful logic you find hiding just under the surface of the numbers we use every single day.